Hello and welcome to helpyourmath.com. I'm Professor Susan LaQuinco, and I thought it would be really fun to put these little videos on the slides, except they come out really grainy. So you're only going to see me on this slide. Hi! This is the Math 157 final exam review question about functions. So let's take a look at evaluating functions in function notation. We're given f of x, so f is our function, and it is the square root of 4x plus 7. So first we want to state the domain of the square root function. The domain of a function is all the real numbers that we can plug into the function that will produce real number outputs. So even though in class this semester we did study complex numbers or imaginary numbers, those aren't in the function system. We only focus on plugging in real numbers and getting real numbers on the backside. So how can a radical steer us wrong? Well, radicals, or the expression underneath them called the radicand, it cannot be negative, right? As soon as we have a negative under the radical, that takes us into the complex number system. So the way we set up the domain for a radical, for a square root, is we say that radicand, 4x plus 7, needs to stay bigger than or equal to 0. The domain will be all of the numbers that I can plug in for x, such that 4x plus 7 will be bigger than or equal to 0. And now what I want to do is figure out what x is, so I'm going to get it by itself. I'll get it by itself by subtracting a 7 from both sides. Now I get 4x is greater than or equal to negative 7. And then I need to divide both sides by 4. And let's see, I can't really divide because 4 doesn't go evenly into negative 7. I can leave it negative 7 over 4. I can put the negative in the middle. I can rewrite it as a mixed number, negative 1 3/4. I can put it in my calculator and get negative 1.75. We have a lot of options. Since I'm not really going to do anything with this, I'm just going to leave it as an improper fraction. What I will do is I will write the domain in interval notation. We're looking at all of the numbers that are greater than or equal to negative 7/4. So that means I'm going to use a bracket to say we're going to include the endpoint being negative 7 over 4, and then it's all of the numbers bigger than negative 7 over 4, so we just say to infinity. Since infinity itself is not a real number, we close it with a parenthesis, and that's the domain for f of x. Now in letter B, it's asking me to evaluate at a specific value, at f of 14. This means I'm going to go into the function, and anywhere I see an x, I replace it with a 14. And 14 is part of my domain, right? Because it is in between negative 7/4 and infinity, so I'm good to go. I have 4 times 14 plus 7. And 4 times 14, that's 28, 56. 56 plus 7, we end up with the square root of 63. 63 itself is not a perfect square, but we want to look or ask ourselves, does 63 have a perfect square factor? Keep in mind the perfect squares are 1, which we don't really care about, no offense, 1, 4, 9, 16, 25, 36, 49, 64, whoops, that's too big. Okay, so are any of those numbers also a factor of 63? And the answer is yes, 9 is, because I can rewrite 63 as 9 times 7. And now I can kind of write this as 2 separate radicals. I'm allowed to do that with multiplication. And I can take the square root of 9. The square root of 9 is 3. And then the square root of 7 just stays this. Because it's irrational, we would just leave it as the square root of 7. Because I want my exact answer. I don't want some weird approximation that I put in the calculator. And so now I would say that f of 14 is equal to a very simplified 3 radical 7, final answer. For letter C, again, I'm going to plug in, but this time, instead of plugging in just a nice, neat number, I'm plugging in a little baby expression. Now, it does say assume m is greater than 1. That you can disregard that. That's just keeping it so that we're not going to end up with a negative under the radical. That's all it's doing. All right, so now we're going to go into that function, and anywhere I see an x, I'm going to replace it with 3m minus 2. What happens when I do that? I have the square root of 4. There's an x. I'm going to replace it with 3m minus 2 plus 7. I want to clean up my radicand using first the distributive property. That would be 12m minus 8 if I distribute the 4 to the 3m and to the minus 2, and then plus 7. And now I will combine my like terms. I have 2 constants, negative 8 and positive 7. Make sure you keep the signs that are in front of them. That's a negative 8 and a positive 7, so we would subtract and I get 12m minus 1. And that's as much as I can do. That would be my simplified function at 3m minus 2, final answer. This has been a look at plugging into function notation. Thank you for stopping by.